Now going on to question number 8. Now we're really on to something. This is a real question here with some real lessons that most students would have to learn. This is something that I would imagine less than 3% of high school students know how to do coming out of high school, unless they're learning it to prepare for the SAT. So what we're talking about is this: the altitude to the hypotenuse of a right triangle. So if you look at that top triangle there, that's a right triangle with the right angle here. And the red line going vertically through the middle, that's the altitude, because an altitude hits one of the sides of a triangle at a right angle. So there's another right angle here, and it's called an altitude because what is altitude? It's height. And this red line here tells us how tall this triangle is. Now, if you want the background, the altitude to the hypotenuse of a right triangle, so it's hitting the hypotenuse, the bottom of it, at a right angle, it actually splits the triangle into 3 similar triangles: the left one, the right one, and the outer shell triangle. You don't need to know all that, but there are 2 rules you need to memorize. The first one is what we call the T rule. So if you have a situation like this and you're trying to solve for the A, the B, or the C. So let's imagine A and B are numbers, but C is still a variable. What you would use is the T rule. It says A over B equals B over C. And we call it the T rule because it creates a T shape when you do it. So one more time, A over B equals B over C. And that's the T rule. It's the easier of our rules for the altitude to the hypotenuse. Now, the next one is what we jokingly refer to as the Nike swoosh rule. We don't want to get into any copyright or trademark issues here, so we'll just call it the swoosh rule. In any case, to do the swoosh rule, the Nike swoosh rule, you start at the place where the hypotenuse is broken into 2 pieces. So remember, the bottom is the hypotenuse, and it's broken into A and C. So you start at the break in the hypotenuse, and then you go toward one of the legs of the outer right triangle. So C over D equals D over the whole hypotenuse, hence the Nike swoosh rule. On this side, it would be the same thing in the other direction. You start at the break in the hypotenuse, which is the bottom. This is the hypotenuse of the outer triangle because this is the right triangle. This is the right angle for the outer triangle. And so you start at that break and you go toward the leg. A over E equals E over E plus C. So let's write those 2 rules out. C over D equals D over the whole hypotenuse. Or if we're going to the other side of it, A over E equals E over the whole hypotenuse. That'll take a little bit of memorization, but what you're hearing here, I think, is the simplest way to lay out the rules for the altitude to the hypotenuse of a right triangle. So now we have a lot of arithmetic work to do here to get to an answer on this question. So let's get started. We have AD is 121 over 3. AB, 11 root 130 over 3. And we need DC, so let's call that X. So we can go ahead and use the Nike swoosh rule. We can start right here, and we're going to go toward the leg. This over this equals this over this. And that'll be our swoosh, or jokingly referred to as our Nike swoosh. So let's do that. 121 over 3 over 11 root 130 over 3 equals the 11 root 130 over 3 over the whole hypotenuse, 121 over 3 plus x. So what we did is this over this equals this over the whole thing. And let's start trying to make sense of all of this. One thing that I might do here, to kind of make this easier to simplify, is multiply the numerator and denominator of both of these fractions by the number 3. If you multiply something by 3 over 3, you're not really multiplying by anything that changes it. You're just multiplying by 1, because 3 over 3 is nothing more than the number 1. So distributing it here, we'll have 121. And here, once again, the 3 cancels, and you'll get 11 root 130. Multiplying it here, you'll get the 11 root 130. And then multiplying it, distributing it to this and also this. That's the more complicated one, but it's still not complicated. That'll give us 121 plus 3x. So to the 121 over 3, it canceled it. To the x, it actually multiplies 3x. So here we are. And now we're in a much better position to cross multiply because we've gotten rid of a lot of these fraction within a fraction situations. So multiplying, cross multiplying, we'll do top left, bottom right, bottom left, top right. So we're just cross multiplying there. And so we'll have this thing times this equals the 11 root 30 times the 11 root 130, the 11 root 130 times 11 root 130. And just kind of doing that, well, let me write it out. 11 root 130 times 11 root 130. Now, on the right-hand side there, 11 times 11 is 121. Root 130 times root 130. Well, by the way, root of x times root of x is simply x. On the other hand, root of x times root of y, that would be root xy. So depending on if the thing underneath is the same or different, you get different behaviors coming out of that multiplication. So root 130 times root 130, well, that's just 130. And distributing on the right-hand side, 121 times 121, that's 14,641 plus 121 times 3, 363x. And now we're multiplying on the right, 121 times 130. That's equal to 15,730. And we're just bringing this part down. Let's take away the 14,641 from both sides. And we'll get 363x equals 1,089. Divide by the 363 on both sides, and x equals 3. And that's what they're asking us for. DC, which we now know is 3.